Okay, so for this question we want to find dy by dx when we're given the parametric equations x equals e to the 2t cos t and y equals e to the 2t sin t. So to start with, you should be thinking, right, well, we're given parametric equation, we want to find dy by dx, so we're going to have to differentiate both of these, in this case with respect to the third variable t. In order to use the chain rule, dy by dx is equal to dy by dt times dt by dx. And for both of these, you're going to look at this and see, well, we've got an e to the 2t, and it's multiplying a trigonometric function, a cos t for the first one and a sin t for the second. And if they're multiplying and we're differentiating them, we're going to need to use one of our rules. Which rule is it? Well, because they're multiplying, it is the product rule. And remember to keep it consistent with our other rule, our quotient rule. We want to use v u dashed plus u v dashed. Okay, like I say, you can have it either way round, but it's better to stay consistent to help you when you're looking at the quotient rule as well. So let's take our first one then. If we've got x is equal to e to the 2t cos t, then our u is e to the 2t. Our u dashed, the differential of this, well, the 2 comes to the front as a multiplier, the exponential stays as it is, so 2e to the 2t. You've got v, which is cos t, and the differential of cos becomes minus sin t. So therefore, for this one, we can say that dx by dt is equal to, we can substitute in our four parts, our v, which is cos t, times our u dashed, which is 2e to the 2t, plus our u, which is e to the 2t, times our v dashed, which is minus sin t. Now, just to make this a little bit easier for ourselves, we can go say, well, we have a common factor here of e to the 2t, so let's take that out. That leaves us with a 2 cos t minus sin t. Okay, so that's our first expression. We now need to do something similar for y. So when y is equal to e to the 2t sin t, again we've got another product, so another product rule, and we need our four parts. Our u again is e to the 2t, our u dashed is the same, 2e to the 2t, our v is sin t, and our v dashed is then cos t. So again, we're using the product rule, so therefore dy by dt is equal to our v, which is sin t, our u dashed, which is 2e to the 2t, plus our u, which is e to the 2t, times our v dashed, which is cos t. And again, just like the last one, let's make this a little bit easier for ourselves and take out this common factor of e to the 2t, leaving us in the brackets 2 sin t plus cos t. So, finally then, we can say, therefore, dy by dx, which is equal to dy by dt times dt by dx. Our numerator, dy by dt, e to the 2t times 2 sin t plus cos t, over our denominator, which is multiply dt by dx, or we're dividing by dx by dt then. So e to the 2t times 2 cos t minus sin t. The final thing that you should notice is our e to the 2t's are going to cancel. So therefore, finally, dy by dx is equal to 2 sine t plus cos t over 2 cos t minus sine t. And that's our final answer. So the dy by dx, when x is equal to e to the 2t cos t and y is equal to e to the 2t sine t, our dy by dx is equal to 2 sine t plus cos t over 2 cos t minus sine t.